Welcome everyone watching on YouTube. So this is our 49th live stream geometry. So we have me and 6 other people here with us right now. And today I'm going to do some more problems from the Taiwan team selection test. So I never realized how many good problems this contest had, but I'm just going to keep on doing them until I run out. So with that, I am going to share my screen. So just a second. Thanks for joining, Malek. Can you all see this? I'm just going to assume. Okay. So here's the first problem. This is from 2018. We have a triangle ABC, circumcircle omega, and we draw the circumcenter and the orthocenter. All right. There's a circumcircle. Let's draw the center. Let's call it O. And now let's draw the orthocenter. Should be the 4th triangle center. So S lies on the circumcircle, so S can be any point. And P lies on BC, so that angle ASP is equal to 90. That's kind of interesting. So basically we want the circle with diameter AS. Let me think of the best way to do that. So I'll draw the midpoint of AS, and then I'll draw the circle through D. So this point right here, oh, angle ASP is 90, not APS. Okay. So then I'm going to want to draw the perpendicular to AS. And I want the point to lie on the segment BC. So I'll figure out how to do that in just a second. So where should I move S2? How about right here? Or something like that. So this is point P right here. And then SH intersects the circumcircle of APS. Interesting. So I'm going to draw the circumcircle of APS. So basically AP is the diameter of that. And SH intersects it at X. I just don't want to make it look like it lies on the side. Maybe something like that would be better. So this would be X. Then OP, we try to see where it intersects CA and CB. So I can draw a ray. That's going to intersect CA really far away. So let me try to move things a little bit. Almost looks like OP is parallel to AC, right? Maybe that might work pretty good. So something like that. Yeah, you see the closer A and S are, the less OP and AC are parallel. But let's see, what if I move A like right here? And this is tricky. Just trying to draw a good diagram. Maybe that'll be good enough for now. Or I'm just going to shrink this a little bit. There, I kind of like that. So I want to label it intersects CA at Q and AB at R. That's Q, that's R, and QY and RZ. Okay, so in triangle AQR, we want to draw the two altitudes. So let's see. So Q to AR and R to AQ. So let's kind of see what that looks like. It's a lot of points here. So QY and RZ. We want to show that X, Y, and Z are collinear. All right, so time to hide a bunch of stuff and then redraw it. There's a decent number of points in this question. Why did I draw this one? I forgot.
ASP is 90 degrees. That's why you wrote it.
Okay. So let me redraw a whole bunch of stuff. So there's ASP, and then so Q was okay. So I draw OP, OPR and Q are collinear, and then Y is the foot of the altitude from Q to AB, and Z is the foot of the altitude from R to AC. I think that's everything we need.
You also need to draw SX.
Oh, HX or SX. Yeah, you're right.
Yeah.
Oops. There we go. So we want to show that X, Y, and Z are collinear. So Y, Z are both feet of altitudes. So that probably gives us some information.
Can you intersect AO and SP?
AO and SP? Or...
Yeah, they intersect on the circle.
Okay. Yeah, because angle ASP is 90, so that makes sense. So those will intersect on the circle.
Also, drawing the orthocenter of AQR may be useful. I mean, you can intersect QY and RZ.
I agree with that. It almost looks like it concurs with SX.
Maybe it does.
Let's check that out. So yeah. So I'm not sure why, but it looks like those are concurrent. So I'm going to draw that. And then also, I guess it might be worth drawing this point because AH passes through this point. Let's check the chat. maybe it's better to draw ES later. Yeah, you might be right. So I'm going to hide that for now. Oops. Sorry, I'm just going to delete that portion of the segment. There we go. Or just hide it. Simpson line needed somewhere. Yeah, Taiwan really likes orthocenter problems. Can I also draw the altitudes from B and C? Yes. Move things a little bit just to add this other point. Hide that. Oh, that almost looks like it passes through O. But yeah, there's so many points in this figure that it's hard to make everything. Maybe that looks better. So PO meets the sides at Q and R. SH meets the circle at X. Yeah, so I don't know if it helps to show that SH passes through E. Maybe it's worth letting H intersect the bigger circle. Yeah, because I think, yeah, if we let SH intersect the bigger circle, I think X is the midpoint of that segment. So oops. So I think X is the midpoint of HJ, and I think that's easy to prove using power of a point. Because if we extend this one to meet the circle at a point K, Actually, let me check that. I'm not sure that's true. Maybe that's not true.
Reflect H over F, then it's obvious.
Oh yeah, if you reflect H over F. Because Hx times Hs is Ha times Hf. Yeah, and then you just double that. And so it's true.
Does y that this is through the midpoint of AH?
That's a good question. Let's check. I think it does. Yes. So basically we have to show, let me just move things around to make sure, but it looks like it. So we just have to show y and z are collinear at that point, and then show z and x are.
Maybe.
Yeah. Is H the midpoint of SJ? No, I don't think so. So X is the midpoint of HJ, but if we draw the midpoint of SJ, that would basically be the perpendicular from O to SJ, and so that's not H. So we want to show Y, Z, and K are collinear, and then I guess X, Z, and K, I'm not sure. Is R, Z, S, X cyclic? Let's check it out. R, Z, yes, and also, does it really pass through C? I think that might just be a coincidence. But maybe it does. Let's check. Yeah.
Actually, it passes through G. 6 points are cyclic.
Yeah, R, Z, S, X, and G. So it looks like all 6 are. Is that? Because RZC is 90 degrees, right? So RC would be the diameter. Wait, no, that doesn't make sense. Wait. So KX is parallel to AJ. Because they're both midpoints. So yeah, KX is parallel to AJ. I agree with that. But let me check something here. So is it true that RSC is a right angle? Yeah, interesting. This does not seem obvious to me. So if those are all cyclic, then by symmetry Q, Y, like there would have to be another one too, right? Q, Y, S. Yeah, so we'd have like 2 of these. But first, yeah. First, let's see if we can show that that one is cyclic. So RZC we know is a right angle. RGC we know is a right angle. So you know RZCG is right. We just need to show S and X lie on it. Yeah. Power of a point from H. Oh, it follows that X lies on it, I guess. Because X, let's see, X is the midpoint. I guess what are you saying follows by power of a point? That it's cyclic, or that X is the midpoint of HJ?
Cyclic. Yeah, I see that too.
Ah, okay. So because we would have XSGC because X is the midpoint of H. Yeah, okay. So we have XSGC is cyclic, and we have RSZC is cyclic, and then I think we still need.
Yeah, we still need one more thing because we don't know they are the same.
Yeah, so I guess I'll just type out those two circles. So we have SGXC and RSGC. Okay. Looks like we have someone else who just joined. Let's see. So yeah, thanks for joining. Okay. So we know these two are cyclic, and we know the radical axis is GC. But then, even if we know that X are SGC. Wait, is SGC on both of these? So we have RZ. Oh, this would be RZGC. Sorry. Even if we know that SXRZ is cyclic, that's still not enough to show that they're the same circle. By radical axis, X, S, and E are collinear. So XS is one of the radical axis, and then RZ. I guess, do you mean, so we have this circle, and what's the last circle? Is it this one, QY? Let's see. Intersect AE with the AFP circle. Okay, hold on one second. Okay. So we have this point right here. Whoops, sorry.
Yeah, and we also know that this point lies on the line RQ because A is the orthocenter of QRE.
Yes. So A is the orthocenter of QER. Sorry, I'm just trying to draw it. But yeah, so that point has to lie on that circle. That is a good observation.
So ALRZ is concyclic.
ALRZ. Ah, interesting. So ALZR and SX are concurrent. And so that means that X, S, and E are collinear.
Yeah.
Nice. So let's see.
Okay, now I think now it's just Simpson line.
Okay. So with point S, the Simpson line of point S.
No. Wait a minute. I'm
Sorry.
confused. I'm sorry.
It's all right. Let me check the chat. Yeah, we still have to show. So we want to show these 6 points all on a circle. We've shown that SCR. Yeah, do we have to show it's cyclic to use the radical axis theorem? Let's see, because that would be SX.
Yeah, I guess because we used XR, ZS is cyclic.
Okay.
If we can show AGCE is cyclic, then the Simpson line of E is gonna be X, Y, Z.
Okay. So the Simpson line of E with respect to which circle?
AGC, I guess.
AGC. Well, I guess the Simpson line. Okay, so we have a perpendicular.
Do we have a CG perpendicular to EX?
Let's see, CG and EX. Well, yeah, I kind of just assumed that was true, but that's not that obvious, right? Is that actually true? I'm not sure. Let me do a little quick check. Yeah, I actually don't think that's true. I think it just sort of looked like it.
I'm wrong then. I'm sorry.
Right. But yeah, I thought that too for a second. So do you want me to delete SZRGCX? So what can't be true? Are you saying that's not cyclic or? Oh yeah. Is JE perpendicular to QY? I'm not sure. I don't think so, but no. Okay. So yeah, let me hide that circle for a second, just so we don't get confused. So this circle right here, let's hide it. So we know that these are cyclic, SGXC. Oh, whoops, sorry. So you want me to hide this one? Yeah.
Yeah, that one.
SZRGCX. We need a line which is perpendicular to JE. Okay, so this circle, yeah, we know this circle exists already. So we know that SXGC is cyclic. We know that RZGC is cyclic. We just need to show one more. We haven't used anything about O. Yeah, because OP intersects. Yeah. So can we show angle RZRSC is 90? SPD collinear. add. So SP and D are collinear because angle ASP is 90. Was there something? I'm sorry, what did, oh yeah, I guess it is something I could write, but yeah. Sorry. Yeah, can we show that angle R?
I think Pascal proves the cyclicity of 6 points.
Oh, really?
Can you intersect CO with the circle?
A TO?
CO.
CO, yeah.
And call it C prime.
Okay. RSC, let's see. So RSC is RSP plus PSC. Hold on, I'm going to first read what Amal wrote, and then I'm going to try the Pascal you mentioned. RSP plus PSC, which is RSP. Oh, okay, that's all right. Okay, C prime CS DAB. DAB. But we know C prime SC is 90, right? Because that's C prime is a diameter, right?
Sorry, I mean
R,
Pascal
yeah.
shows that R is on C prime S.
Okay. So because that would mean PO and that other point are collinear. Okay. So I think that should be enough because once we know that angle RSC is 90, that means all these points are cyclic. And yeah. Okay, and then once we know that, did we solve the problem?
Actually, I think now we can calculate YZX angle.
We can calculate YZX. So is that the angle that YZX makes with something, or is that like angle XZR plus YZR we could show as 180 or something like that?
XZR plus YZR
is 180.
Yes.
Okay. Yeah, because then yeah, we just have angle EZY is EAY is LAR is let's see. So RZX. What does RZX equal to? So do you know how I would find angle RZX?
No, I'm trying to.
That's okay. GX. But yeah, we're getting really close. So yeah. I'm just going to leave this up here until then we'll start writing it in the end. Okay, so Pascal on C prime DAB. CC prime S DAB. All right. So we have CC prime intersect AD, and then we have BC intersect SD, and then we have C prime S intersect AC. RZX. So we want to show angle LAR is equal to angle RZX. So maybe it's worth see, we want to show LAR equals RZX. Sorry. LAB is RZX. Or we could just try to show ZX bisects AH and so does YZ.
So we just need to prove that QESR is cyclic, I guess.
QERS.
Yeah. Can you check it?
Yes. The Khan thinks he has a solution. QERS. Yes.
If we prove this, we are done from angle chasing.
Okay. Let me see. So Khan says angle KXH equals ZXH. All right. So I'm going to start typing out the solution. I'm sure there's a way to do it showing that that is cyclic. It's probably just some kind of angle chase. But I am just going to start typing out what Hakan wrote. So see if this works. So I'm going to fill in the stuff before, after. Okay. maybe I'll break it up into 2 lines. Couple extra spaces here. Whoops, it didn't. Let me do this.
Yeah, I found a way to do it.
Oh, you found a way to do it?
Yeah, it's another angle chasing.
Okay. I'm just gonna type this one up for now, but
Yeah, type it. I'm writing in the chat.
okay, sounds good. Okay, so first, okay, let Sx meet gamma at J. Amateur of gamma. Let's break this up. There we go. So first we have angle RGC. Is G in the question? Let G be the foot of the altitude from C. Altitude from G and or what are the altitude from C? So we have angle RGC equals RZC equals 90. That means RZGC is cyclic. And then I could say let so yeah, I mean, basically we know X is the midpoint of HJ by power of a point. And then, yes, basically, I'll say let CG meet the circle at a point. I don't know. I'm just trying to. Okay. Interesting. I was just reading what Serdar wrote. So SGXC is cyclic because X is the midpoint of HJ. So I'll write it like this. So AFP, so SH, we have SH times HJ equals CH times HM. That implies, so, and that's CH times 2HG. And so that implies HJ equals 2HX. And that implies that SGXC is cyclic. So quick. And then we have that angle chase. So by Pascal's on that, let R, what was the point we added? L. So, wait, we wanted to show, sorry, I forgot. We want to show CR and SR collinear, and we could do that by Pascal's on CC prime. Okay, so it's all right. I think there's a bunch of ways to solve this, it looks like. So by Pascal's on that hexagon, we have R, O, and P are collinear. I'm sorry, C prime, R, and S are collinear. Whoops. Sorry, my bad. So Pascal's theorem says C prime, R, and S are collinear. And then once we know that, do we also have to show S, X, and E were collinear? I forgot how we did that.
We show that. Actually.
We did, yeah. We. I know we mentioned that earlier. I'm trying to remember how we did that.
By radical axis.
That's right, the radical axis theorem. So let AE intersect the circle AFP at L. And then by the radical axis theorem on AZRL, we have AZRL, and then ZRSZRX. And ALSX, yeah. Then we have S, X, and E are collinear. All right. It's like Dat is about to join us. Dat Feng. Okay, and I think, so did we use point R So yeah, I think Dat was about to join. Did he join? Oh, thanks for joining, Dat.
Oh yeah, I'm here.
All right. So we didn't use E, did we? Yeah, maybe we didn't. So wait, let me, let's see. Anything about this angle KXH KXH equals AJH, which is AJS, which is ACS, which is ZCS, ZCS is ZXH. So yeah, we showed Z, K, and X are collinear. And then, okay, so this means that Z, K, and X are collinear. And then how do we show Y, Z, and X are collinear? Like, I think we're still missing something, right? So Z, K, and X are collinear. Oh, by the same argument, Y, K, and X are collinear, right? So it's kind of a symmetric argument. And that implies X, Y, and Z are collinear. Yeah, so I don't think his solution uses point E or L. So I think Serdar's solution, Serdar had a solution using point E. So E and L. But Hakan's solution, it looks like it doesn't use those points. Interesting. So I want to add one note. So once we showed that HJ is 2HX, then we have KX is parallel to AJ. We'll just add that right there. We just make some room for, because sometimes on YouTube, like the very bottom line doesn't show. So I'm just making some room and then I'll move on to the next problem. But yeah, so we have one argument that uses point E, and then we have another argument that I don't think does use point E. So that's cool. All right. So we'll move on to the next problem. So we have a triangle ABC, and we draw the incenter, centroid, and circumcenter. Oops, sorry. So that's O. And then I is the incenter. So what I'm going to do, I'm going to draw the incircle. And then I is the center of D. There's the incenter. And G is the centroid. Do you know which triangle center that is? 2. Okay. So there's G. And we have BX equals CY equals AZ. So X is on BC. So I'll just call this X. And let me use the compass tool, which I really like. compass, bx, and then do it again. Whoops. That's not what I wanted. Sorry. Oh, that's because I got to use a compass again. bx equals cy equals az. Y is on CA, and Z is on AB. F is the centroid of XYZ. That's interesting. So I'm just going to hide it later. So F is that's F. So let me make the diagram look a little better. We want to show FG is perpendicular to IO. So let me make F and G a little farther apart. They're so close together, it's hard to, I'm not sure how to make them farther apart, because if I do a taller triangle, maybe I just need a really like wide, or let me just X, that might make it better. Yeah, we want to just X. All right. Just read your comment, Animal. So this is interesting. So there's a lemma that Nguyen is saying. Let D and E be on AB and AC so that BD equals CE. Interesting. Maybe that's like a degenerate case of this. So if X is set to be equal, so I think that's probably a degenerate case of this, but it could be that it also could be used to prove it. So let's say like we have a really tall triangle like this, right? And let's say that we set point X to be point C. Then it's saying, yeah, so I think that's like a degenerate case. Oh, wait a second.
This is more general.
This is what?
This is the generalization, maybe.
A generalization of that. So, but is it a general? Oh, I guess when X is point B. Well, no, actually, is it a generalization? BD is equal to CE. So D is on a B. BD equals CE. Yeah, exactly. I don't think it is a general. I think it's just a different problem. But maybe we could use that to solve it. I don't know. So I'm going to try, because I think I did a problem like that on my channel before, right? Like, so Nguyen is saying if we draw these 2 points, and he's saying that that is perpendicular to OI, which is like a little bit different. I don't think it's just a degenerate case. So
this is what he said.
Yeah, so he said that DE is perpendicular to OI, and we're trying to show FG is perpendicular to OI. And I think I did this on my channel once, where I showed DE is perpendicular to OI. I think that was another video. So if we could show DE is parallel to FG, that would also solve it, it looks like. Yeah. Do we want to delete I and O? Yes, we could. Just try it for now. So obviously FG doesn't pass through C, it just looks like that. Yeah, the end circle 2. Even the circumcircle, really. Okay.
EY equals to XC.
EY equals XC. Interesting. And BX is equal to DZ. So yeah, we could hide the circumcircle too, even, right?
Actually, I guess it's not true. DZ equals to BX.
That DZ equals BX.
Yeah.
Wait, why would one be true but not the other? Am I missing something?
Because it's not symmetric.
Oh, you're right. Yeah, it's not symmetric. So EY equals XC and CY is BX. So one second, guys, I'll be right back. All right, so complex fashion. Let's see. So thanks for waiting. Let's see if we can find a solution without complex numbers. So okay, so we have something like this, and G is this, F is the centroid of XYZ, and G is the centroid of ABC. So yeah, in fact, maybe it's just like, So we want to show DE is parallel to FG. Is there like a homothety?
Are these triangles similar?
Which ones?
XYZ and ABC.
Let's see. Don't think so. Oops. But yeah, I don't think those add up to 360. So let me just do it the other way. No. So yeah, we want to show the line joining the centroids is parallel to DE. It almost looks like vectors would be an interesting way to solve this. So do we want to draw the midpoints of BC and YZ? That might be the best. So G is 2/3 of the way from A to H, and F is 2/3 of the way from X to G. So yeah, this almost seems like a vector calculation, right? So we want to show that DE is a scalar multiple of the vector DE is a scalar multiple of the vector GF. So G is 2/3 of the way from A to H, and H is the average of B and C, and F is 2/3 of the way from X to J, and J is the average of Y and Z. And then so GF would be the difference between those two, and then DE I think vectors would probably do it, but I wonder if AH passes through. No, I don't think AH passes through the midpoint of DE. A projective geometry. Yeah, let me think if we could do it that way. Oh, okay. You're talking, so vectors doesn't seem that easy, basically, is what you're saying. How do we write, So BD is a certain multiple of BZ, right? So, let me think about this. So, or we could say BD. Okay, so D is A over C times A plus C minus A over C times B. And then we could do something similar with point E, right? So we would, and then, okay, so D and E we can get, and then X, Y, and Z. No, but X, Y, and Z, we don't need lengths, right? So H is B plus C over 2, and then G is 2/3 H plus 1/3 A, right? So like, but F, okay, so F, so J is Y plus Z over 2. Oh, yeah, you're right. We could do that. Yes. But, and then, so how do you write X? How do you, I'm sorry, how do you write Y and Z? It's probably something similar. Yeah. Like, yeah, this problem just seems like vectors, right? So I'll write out all the points. So let me just write out everything we have. So okay. So yeah, maybe I could probably just delete AH and XJ. So we have, let me write this all out. Just gonna copy what you put. So you have G is 1/3 A plus B plus C. And then we have that. Oops. And this. And then X this. Right, is there a way to copy this? Let's do this. So F is a third of X plus Y plus C. And then we also have E. So the vector DE is what you get when you subtract these two, right? And we want to show it's proportional to what you get when you take subtract these two. So basically this would be a third of A minus X plus B minus Y plus C minus C. So let's write out Y. Okay, so we have X. Then we just need Y and Z. Let's see. So yeah, Y and Z are similar to X. So Y is T over B times A plus, so it would be B minus T over B times C. I think that should be right. And then Z equals T over C times B plus C minus T over C times A. So if we average these three, that's what F is. And then if we average A, B, and C, that's what G is. So basically this is a third. And we want to show that's proportional to the difference between these. Yeah, this is a little messier. I guess you're right, it's kind of messy, right? Because how does the T, let's see. Because there's no T when you, so yeah. So I guess one good thing is there's like a C minus T over C. That's the same as like 1 minus T over C times A. So you have like an extra A, B, and C here. And when you take the difference between F and G, so it's kind of like the vector, yeah, so the vector GF. Oops. I don't know how to do the little vector thing, but it's It's equal to a third of x minus b plus y minus c plus z minus a, and then things cancel, so that's equal to p times, let's see, we have one new message. Yeah, computation, I'm sorry. Let's think about this. So this would be a t over a times b and t over c times b. So so we would have t times b, it would be t times b times 1 over c minus 1 over a plus c times 1 over a minus 1 over b plus a times 1 over b minus 1 over c. So a third. Okay, so basically this is FG. I don't know how to do the little vector thing, but is that right? Or we could.
Michael.
Mm-hmm.
I think we could use vector. We don't need to, use this thing. Just use the vector. Vector fg is a third of fa plus fb plus fc.
Mm-hmm.
Yeah, and from that you can calculate. Okay. You could write this solution, and I could write my solution on the chat for everyone.
Okay, sounds good. Thanks, Feng. Yeah. I just use vector, so I feel like a synthetic solution here would just be like a lot of like parallelograms and stuff. So I feel like it might just kind of be the same thing as a vector solution. That's the only reason why I decided to use vectors here. But yeah, no, I agree, Animal. So FG is that expression. We could also say like 1 over c times b minus a plus, yeah, there's like other ways of writing it. So if we take dE, then that vector, okay, so yeah, basically this would mean the t drops away, right? And so, because we just want to show FG is proportional to dE, right? Yeah, so, So maybe we could factor an A out of this. So, because like if we take DE and we divide it by A, here you can see the A times the 1 over B minus the 1 over C. And then, so let's see. So yeah, I think we're actually really close here. So the vector DE, it's I'll write it like this. It's 1 over A times, this would be A times 1 over B minus 1 over C. And then if I do this correctly, it would be like 1 over A. Oh yeah, you're right. 1 over just A. So yeah, A times that, and then minus C over A plus B over A. And then plus BA over C, plus BA over C, or plus, let's see, minus B times 1 over C. No, this should be B times 1 over C. Yeah, we're really close, yeah. B times E times 1 over C. Is it really that simple? Wait, sorry. But yeah, but we are really close here. So yeah. Should be plus B times 1 over A. And then, so yeah, does this just basically solve it? Because, no, I think my adding and subtracting are backwards. Should it be like a minus? Because in order for this to look like this, we want like a minus. I just already know the answer, so I'm trying to force it. But maybe this should be A times 1 over C minus 1 over B. Okay, so yeah. So this should be 1 over A. Tell you what, I'll just do it like this. I think it should be like this. ED is A times 1 over C minus 1 over B. So yeah, everything is flipped DE versus FG. So since DE is a multiple of FG, FG is parallel to DE. So ED is parallel to FG, and that implies FG is perpendicular to IO. Okay, so first I never wrote out the lemma we used initially, but so I'm going to write that out now. But I'm sure this could probably be turned into a synthetic proof. But it would just be like a lot of like parallelograms and stuff. Oh, the definition of E, it should be B minus A over B. Okay. That is my bad. So DE, I'm just going to leave it like this for now, just so we can move on to the next couple questions. But yeah, I kind of did, because there's not like a huge amount of information. So let D be on AB. such that BD equals CE. And then from a previous video on my channel, I'm pretty sure I did it on my channel before. Perpendicular to IO. So yeah, that's what Wynn brought up. And then, yeah, the rest, there might be a mistake, but I'll just leave it to the viewers to check it. But yeah, there's probably a synthetic way to do all this. C times 1 over B. Oh yeah. So the second one, there we go. All right.